Hi, are you frustrated about the concept of minimum spanning tree? Don't worry, my name is Abhinav Krishna. I am here to clear your doubts on it. Without much discussion, let's dive in. What is minimum spanning tree? MST. A minimum spanning tree is defined as a spanning tree that has the minimum weight among all the possible spanning trees. A spanning tree is defined as a tree-like subgraph of a connected, undirected graph that includes all the vertices of the graph, or, to say in layman's words, it is a subset of the edges of the graph that forms a tree, acyclic, where every node of the graph is a part of the tree. The diagram below represents the construction of a minimum spanning tree. As you can see, we consider only the edges with smaller weight until they form in cycle. Now let's look into some important properties of minimum spanning tree. First one. The spanning tree should not be disconnected, as in there should only be a single source of component, not more than that. Second one. There is a fixed number of edges in the spanning tree which is equal to 1 less than the total number of vertices E equals V minus 1. Third one. The number of vertices, V, in the graph and the spanning tree is the same. Fourth one. The spanning tree should be acyclic, which means there would not be any cycle in the tree. And the last one. The total cost, or weight, of the spanning tree is defined as the sum of the edge weights of all the edges of the spanning tree. Now that we have explored how minimum spanning tree works, let's dive into the concept of Kruskals algorithm, a method to build an MST. The below represents the working of Kruskals algorithm. In Kruskals algorithm, sort all edges of the given graph in increasing order. Then it keeps on adding new edges and nodes in the MST if the newly added edge does not form a cycle. It picks the minimum weighted edge at first and the maximum weighted edge at last. Thus we can say that it makes a locally optimal choice in each step in order to find the optimal solution. Hence this is a greedy algorithm. Are you confused a bit? Okay, then let's have a diagrammatic representation to make you more clear on the concepts. The given graph contains 9 vertices and 14 edges. So, the minimum spanning tree formed will be having 9 minus 1 equals 8 edges. Now we begin with sorting the edges in ascending order. Now pick all edges one by one from the sorted list of edges. Step 1. Pick edge 7 to 6. No cycle is formed, included in the minimum spanning tree. Step 2. Pick edge 8 to 2. No cycle is formed, included in the minimum spanning tree. Step 3. Pick edge 6 to 5. No cycle is formed, included in the minimum spanning tree. Step 4. Pick edge 0 to 1. No cycle is formed, included in the minimum spanning tree. Step 5. Pick edge 2 to 5. No cycle is formed, included in the MST. Note: to make the concepts more visually appealing for each step, I have included the diagram of updated MST. Please make a note of it. Step 6. Pick edge 8 to 6. Since including this edge results in the cycle, discard it. Pick edge 2 to 3. No cycle is formed, include it. Step 7. Pick edge 7 to 8. Since including this edge results in the cycle, discard it. Pick edge 0 to 7. No cycle is formed, include it. Finally, we have reached the last step. Step 8. Pick edge 1 to 2. Note: since the number of edges included in the MST equals to V minus 1, so the algorithm stops here. Following are the edges in the constructed MST 2 to 3. White equals 40 to 3. Weight equals 50 to 1. Wheat equals 10. Minimum cost spanning tree equals 19. Let's have a look into the time complexity and the auxiliary space of the algorithm. Time complexity equals order of E asterisk log, or order of E asterisk log V. Sorting of edges takes order of E asterisk log time. After sorting, we iterate through all edges and apply the find union algorithm. The find and union operations can take at most order of log V time.so. Overall complexity is order of E asterisk log plus E asterisk log V time. The value of E can be at most order of V square, so order of log V and order of log are the same. Therefore, the overall time complexity is order of E log, or order of E log V. The auxiliary space, order of V plus E, where V is the number of vertices and E is the number of edges in the graph. To wrap up, Kruskals' algorithm connects all points in a network without loops, making it crucial for systems like roadways and networks. Thanks for watching. Please do subscribe to my channel. Signing out with a spark, Abhinav Krishna.